Welcome, class. Today's lesson is going to be on impulse momentum theorem. So what does that mean? Impulse momentum theorem means that linear momentum and linear impulse are going to be equal to each other. If we break that down into these two equations, linear momentum, linear impulse, we take a look. Simply, linear impulse means that it's the change of mass and velocity over time. In our case, our mass is going to be constant and our velocity will be changing. So we can simply say it's m delta v. Our linear impulse is going to be a force over a change in time. Our force is constant, our time will be changing. If we take a look at two pretty basic pictures here, what we're going to see is this is our cup that will be on the table. We have our tablecloth and then our force of our tug. We have two different pictures. This one represents a longer time, and this one represents a shorter time period. Over a longer time period, this force is going to be applied to our tablecloth into our cup. So what you'll see is that the force of the friction will allow the cup to move with the tablecloth. In the reduced time period, what will happen is that the tablecloth will slide out from underneath. So if we take a look at this example over here, in this equation we have linear impulse on the left side, linear momentum on the right side. Our force and our mass are constant. So what we need is our velocity to be zero. Well, how do we do that? Well, we need our change in time to be zero. So that means we need to do that as quick as possible. What you're about to see in our video are two different examples, one successful and one unsuccessful. The successful rate is the one where the time is reduced to as close to zero as possible, allowing the cups to stay on the table without any spillage. The second one is an elongated time period of pull, meaning that the friction will be applied through the tablecloth into the cup, spilling the water onto the floor.